All right, in this lesson we're going to look at solving equations involving absolute value and inequalities involving absolute value. Remember the idea that absolute value is talking about your distance from zero. Okay, so that's actually our definition, is absolute value is how far something is from zero. Therefore, what we have is we have something that's going to be that distance to the right of zero and that distance from the left of zero. Okay, so when we take the absolute value of 6, what we're saying is how far is 6 from 0, which is 6 units. How far is negative 6 from 0 when we ask the absolute value of negative 6? 6 units. Yeah, back in the day you were told that it was always positive, and that's your reasoning. Now when we start solving equations that involve absolute value, I want to know in this case the absolute value of what number or numbers is equal to 18. What I'm asking is what number or numbers are 18 units from 0. So when we look at that number line, we start at 0, we can walk 18 steps to the right, we can walk 18 steps to the left, and that's what we find out. And so what we're saying then is when I plug in negative 18, I get 18. And when I plug in positive 18, I get 18. Now, how we're going to set up our equations is similar to what I have there now with the 18s. I'm going to talk about this piece as the opposite of what's inside. Okay. The opposite of what's inside. That's going to be 18 units from 0, as well as what's inside is 18 units from 0. So how that's going to help us solve equations, what we're asking here is we got some numbers that are 9 units from 0. And when we find that distance, what we're going to do is 2 times some number, and we're going to take away 3. They're going to be 9 units from 0. How I'm going to set up my equations is in one case, I'm just going to take what's inside. That goes back to this situation. Okay, I'm going to take what's inside, and I'm going to set it equal to what is on my outside. And truly what we're doing in our first situation is just throwing away the absolute value signs. The second case, I'm going to do what I looked at here. I'm going to take the opposite of what's on the inside and set it equal to the outside. So the opposite of the inside and set it equal to the outside. Okay. So now there's a couple ways you can treat that. One, you could do it this way, where I take opposite, again, don't read it necessarily as negative, but it's the opposite of 2x minus 3, sorry. Okay. Or some of you may be able to just go in, well, I'm taking the opposite of the 2x, the opposite of negative 3, and solving it that way. If you set it up here, you'll get to the same point once you distribute that negative 1. And now we just solve our 2 equations. Okay, so over here we'll add 3 to both sides, divide by 2, and find out that one of my solutions is x equals 6. That's a number that when I double it and take away 3 is going to be 9 units away from 0. Over here we'll subtract my 3, divide my negative 2, and we'll get negative 3, which is my second number there. When I double it and take away 3, the absolute value of that will be 9. Okay, and we should always check. So 2 times 6 is 12, minus 3 is 9, absolute value is 9. 2 times negative 3 is negative 6, minus 3 is negative 9, absolute value positive 9. So they do work. All right, one of the things in this equation is you have 2 times that absolute value of x minus 7 plus 9. Okay, so we're talking about that being 14 units away from 0. Okay, well, it gets a little tricky sometimes with this. So number one, what we always want to do is get your absolute value alone. I want to look at in terms of, hey, I have something that's some number of units away from 0. Okay, not 2 times something plus 9 is some units from 0. So this is almost like an equation where I'm going to treat this as my variable. Maybe I switch it to y. So I'm trying to solve 2y plus 9. So I'll take away the 9 for both sides first. And then I'll divide both sides by 2. And now I'm ready to set up my equations. Okay. So we first get to this point where I have my absolute value all by itself. And now we set up my two equations. First one again, inside equals outside. Opposite, so opposite of x, opposite of -7. And my outside is always going to stay the same because that's that distance we're talking about from 0. And now we're just going to sit there and solve. And so again, you may run into situations where you have fractions. So what you're going to have to do is think about common denominators. Okay, so one of my solutions will be 19 halves. Here, if I take away the 7, okay, I'm going to take away 14 halves. Don't lose your minus sign that's with the x, so it's the opposite of x, equals -9 halves. Sorry, -11 halves. Nope, it was -9 halves. And then we take our sign change because we're dividing or multiplying by -1. And there's my two solutions. And again, we should go back and always plug back into our original equation just to make sure those things work out. All right, so when we get to inequalities, there's a number of ways that you can treat these. Teachers will teach you how to solve them keeping the inequality sign. I'm going to teach you how to do it without keeping the inequality sign because I think sometimes there's fewer errors that go about it doing it that way. So number one, we want to solve it just like it was an equation. So I want to solve it as if I had the absolute value of x plus 4 equal to 11. So we just talked about inside, outside, opposite, the inside, outside. Subtracting 4 here, we get one of my solutions to be 7. Add 4 over here. Take the opposite and get our -15. Okay. So that part is just a continuation of what we've been doing. Now what I'm going to do is I'm going to put those two numbers on the number line. And don't do this. See, too often people just put the 7 then the -15 because the 7 was the first one they got, 15 was the second one. But you got to remember that -15 is smaller, so it needs to go to the left. Okay. Because of my inequality sign, it is strictly less than. We use the open circles again. Okay. Had we had the equal sign in there, we would have closed those circles out because of the fact that those would have made the two sides equal, and we would have wanted to include those in our solution set. Now, what I'm going to do is test a point. And I always like to test 0. And when I plug 0 back into my original and simplify it out, I get a statement that's true. Now, what's going to happen here is you're going to get one of two situations in general. You're going to get a situation where the inside is true like we have here, and then the outsides are false. Okay. The other possibility is that you could get a situation where the inside is false and the outsides are true in general. And so I always tell people check one more point just in case. And I'm going to always usually go to a positive value. And so when I plug in 10 this time, okay, it becomes 14. I'm expecting it to be false, which it is. Okay. Now, depending on which situation we have, we're going to have a compound inequality here. This situation, again, remember when it works on the middle, is your AND situation. And so I think it's easiest I tell people just think about here's my two values that I'm checking between. Put your variable in the middle, and your sign's always pointing to the left. Okay. When we're on the outsides only, that's our OR situations. My x could be less than this first value, or my x could be greater than the second value. Okay. Ors, again, we have to satisfy one condition. Okay. Ands, we have to satisfy both conditions. All right, so hopefully this will make this section a little easier for you. Good luck with the homework.